Welcome back, dear all, in our next session on initial tension in the belt drives. So, we already know about the belt drives. One is the driving pulley, which is connected with the driving motor, and the other one is the driven pulley, which is connected with the driven shaft. So, the belt passes from the driving pulley over the driven pulley. So, as we already know that the motion transmission from the driving pulley to the driven pulley through the belt is due to frictional grip between the pulley and the belt. To increase the frictional grip, the belts are slightly tightened so that increased tension will cause a firm grip between the belt and the pulley. Even while mounting the belt on the pulleys, this initial tension has been applied before before the pulleys are running. So even at the start of when the belt and pulleys are stationary, this initial tension is present. This tension is called as initial tension. There are few assumptions while considering the effect of initial tension. One is the material is perfectly elastic, means while you remove it, so it will regain its original size and shape, and even while the initial tensions are applied, the length of the belt remains unchanged. Now let's see what is the formula for initial tension in the belt drive. So initial tension in the belt drive is given by T0 equal to T1 plus T2 divided by 2. So it is average of the tension on the tight side and the slack side. This indicates that when the pulleys are running, so this initial tension gets redistributed. The tension on the tight side increases and simultaneously the tension on the slack side decreases, but the average tension remains same. That is called as initial tension. While considering the effect of centrifugal tension, this can be rewritten as T0 equal to under bracket T1 plus T2 plus 2 Tc divided by 2. So while centrifugal tension is considered, T1 gets modified to T1 plus Tc and T2 gets modified to T2 plus Tc. So that equation becomes T1 plus T2 plus 2 Tc divided by 2. Now let's see a numerical based on the effect of initial tension in the belt drive. A single V belt is used to transmit the power from grooved pulley of pitch diameter 200 mm running at 1500 rpm to a pulley of diameter 600 mm. The center distance between the pulleys is 1000 mm. The mass of the belt is 0.3 kg per meter. The coefficient of friction is 0.25. V-belt groove angle is 38 degrees if allowable tension is 800 newtons. Determine the power transmission capacity of the belt and the initial tension required in the belt. So first thing we need to analyze the given data. So pitch diameter of the pulley is 200 mm. It is not meter, it is mm, running at 1500 rpm to a pulley of the diameter 600 mm. So one pulley diameter is 200 mm, other pulley diameter is 600 mm. The driving pulley runs at 1500 rpm. The center distance means x is given, so x is 1 meter. Mass per unit length is also given, it is 0.3 kg per meters. The coefficient of friction mu is also given, it is 0.25. V belt groove angle is 38 degrees. So the type of belt is V belt and the groove angle, that is 2 beta, it is 38 degrees. Allowable tension. So maximum allowable tension is given as 800 newtons. Determine the power transmission capacity. So P has been asked and the initial tension required in the belt. So initial tension T0 has been asked and power transmission capacity of the belt has been asked. One thing I should remember from the analysis of this question is the mass per unit length of the belt is also given over here. So whenever mass per unit length of the belt is given, it is expected that you consider the effect of centrifugal tension in the belt drives. So even though it is not mentioned in the entire question, but still as mass per unit length is given, that's why you need to consider the effect of centrifugal tension in the belt drive. So let's write down the given data. The given data, D1 is 200 mm, so it is 0.2 meters, so correspondingly R1 is 0.1 meter and R2 comes as 0.3 meter because D2 is 600 mm. N1, that is speed of driving pulley, is 1500 rpm, center distance 1 meter, mass per unit length, this M is not mass but it is mass per unit length, so it is 0.3 kg per meter. Mu is also given, it is 0.25. 2 beta is 38 degrees, that's why beta will be 19 degrees. Maximum allowable tension, Tmax is given as 800 newtons, and we have been asked to find initial tension T0 and power to be transmitted. So first T0, let's write the equation of T0 considering the effect of centrifugal tension. So the equation comes as T0 equal to T1 plus T2 plus 2Tc whole divided by 2. So you can observe here, we don't know T1, we don't know T2, and Tc is also unknown. So there are 3 unknowns in the entire equation, so we cannot solve for T0. So T1 and T2 and Tc, all 3 things we need to find. Remember, T1 is not Tmax right now because we have to consider the effect of centrifugal tension. So let's find all 3 individually. So we need to find Tc, T1 and T2. First let's find Tc. So how to find Tc? We have the formula for Tc equal to mv square. So mass per unit length is given, but velocity of the belt is still unknown. So we can find the velocity of the belt by using the formula pi d1 n1 upon 60 or pi d2 n2 upon 60. So velocity of the belt pi dn upon 60. Once we find velocity of the belt, we can easily find centrifugal tension Tc. Now how to find T1? So we have the formula maximum allowable tension Tmax, which is already given. Tmax is equal to T1 plus Tc. As Tmax is given and Tc we had found from here in this equation, so we can put the value of Tc over here and we can easily find T1, that will be the single unknown in this equation. So that's how we are going to find T1. Now how to find T2? So by taking the initial tension ratios, T1 upon T2 is equal to e raised to mu theta cosec beta. Remember this cosec beta. This is because the type of belt is V belt. So we are solving the question on the V belt, right? So T1 upon T2 is equal to e raised to mu theta cosec beta. As we cannot solve cosec beta in our scientific calculator directly, we can take it as 1 upon sin theta. So this remodified equation will be T1 upon T2 is equal to e raised to mu theta upon sin beta. As theta is unknown, so we can find theta by the equation. Theta is equal to 180 plus 2 alpha because it is not a cross belt drive. So it is open belt drive, that's why we have to use equation theta is equal to 180 minus 2 alpha. As alpha is also unknown, so to find alpha is equal to sine inverse R1 mod of R1 minus R2 divided by X. R1, R2 and X, all 3 are known, so we can find alpha here. Once we put the value of alpha over here in this equation, we can find theta. In this equation, mu is known, beta is known, so we can easily find the right hand side of this equation, e raised to mu theta cosec beta, and on the left hand side T1 is known from this equation, so we can find T2. Once we find all 3 T1, T2 and Tc, we can put over here in this equation and we can find T0. Once we find T1 and T2 both and velocity of the belt from here, so we can also put all three things in the equation of power. Power is equal to T1 minus T2 into V. So we can find the power easily. So let's solve it step by step. Alpha is equal to sin inverse R1 minus R2 divided by X. Put all the values, we can find alpha. R1 is 0.1 and R2 is 0.3. As we had taken the mod, so we need not to consider the minus sign. 11.53 degrees is alpha. Put alpha in the equation of theta. So theta comes as 180 minus 2 alpha. Put all the values and theta we will get 156.92 degrees, but we don't need theta in terms of degrees, but we need it in terms of radians. That's why we need to multiply it with pi by 180. So the equation we will get, the value of theta we will get is 2.73 radians. Now let's find velocity of the belt. So velocity of the belt is given as pi d1 n1 upon 60. All things are known. So put all the values. D1 is 0.2 and N1 is 1500. Put all the values and you will get the velocity of the belt as 15.71 meters per second. So we had found the velocity of the belt. Now let's find centrifugal tension. It is given as mv square. M is given and V we had just found out in the previous slide. So put all the values and we will get the value of TC 74.04. remember its unit is newtons. Now let's find T1. So we know the equation. Maximum allowable tension in the belt drive is given as T1 plus TC. Tmax is given and TC we had just found. So put both the values in this equation. Only T1 is unknown, so let's find T1. So T1 comes as 725.95 newtons. As we had found T1, now we can find T2 by taking the limiting tension ratio. So T1 upon T2 is equal to e raised to mu theta cosec beta. As we don't have function of cosec in our scientific calculator, so rewriting this equation as e raised to mu theta upon sin beta. Instead of taking T1 upon T2 is equal to e raised to mu theta cosec beta, you can directly write T1 upon T2 is equal to e raised to mu theta upon sin beta. Still this equation is correct. So put all the values. T1 is known, theta we had found out, that is 2.73. Mu and beta both are given. 2 beta is 38 degrees, so beta is 19 degrees. Put all the values in this entire equation. Only T2 is unknown, so find T2. T2 comes as 88.64 newtons. So we had found T1, T2 and TC. So put all these in the power equation, so we can find the power. Power equation comes, put all the values T1, T2 and velocity of the belt. We'll get the value of power. So it is 10,012.3 watts. Remember the unit is watts over here. So we can find power in terms of kilowatt also. So it is 10.01 kilowatts. So one thing we need to find was power. So we had already found it. Now let's find initial tension. So next equation is initial tension. T0 is equal to T1 plus T2 plus 2 TC. Remember this 2 TC is because we have to consider the effect of centrifugal force or centrifugal tension. So put all the values T1, T2 and centrifugal tension. So the final value comes as T0 equal to 481.34 newtons. So this initial tension has to be maintained while employing the belt on over the driving and driven pulleys. So two things has been asked. First thing is power. So we had found out it comes as 10.01 kilowatts, and other thing we had to find is initial tension T0. So we had found T0, it comes as 481.34 newtons. Remember the unit as newtons. So our question is complete now. Thank you all of you.